Okay, welcome to your last video. We're going to finish up Unit 1 today, and I'm feeling excited for you guys because you're almost done. This, I hope, will be the fastest, although I've said that before, and I guess it's not turned out to be that way. I almost feel like I could skip this video, but I'm not going to. I'm going to remind you of some things. It's heavy on review. An ionic bond is when you have the transfer of electrons, okay? It's going to be a metal and a non-metal. Now, when you have a non-metal and a non-metal, that's a sharing of electrons, and that is covalent bonds, okay? So transfer is metal and non-metal or ionic. It's when you make charges. Now, we will be talking about covalent compounds if they are polar or nonpolar later, okay? But this section is just about ionic compounds. Now, you can look at an electron configuration to determine if an element wants to gain or lose electrons. The whole thing here is that we want that outer shell, the S's and the P's, to have an octet, or to have 2 in the S's and then have a full P with 6 to get 8 total. A cation is a positively charged ion, and metals generally do that because they give away electrons. A lot of students will say positive T because you got the T in the cation, okay? A negatively charged ion is usually formed by nonmetals, and it is because you gained electrons, and it would be like maybe chloride, and then like a cation would be like maybe magnesium. Ionic compounds are held together by an ionic bond. Okay, they're held together by an ionic bond. Now, I do want you to memorize some of the transition metals where you can't predict their charge. I asked you in 10th grade to memorize Ag1+, and that is on this list here. I'm not going to ask you to memorize cadmium or zinc. Zinc's probably good to memorize, but I wanted you to know that copper can be +1 or +2, and I asked you to know that Fe is +2 or +3. Knowing that zinc is +2 is helpful. Maybe you want to add that to your list. Lead is another one that has optional charges. Remember, these would be the things that if they have more than one option, you'd want to use Roman numeral when you name them. Now, whenever you do ionic compound formulas, you have to understand that the number of electrons lost must equal the number of electrons gained, or there must be a balanced charge. We call this sometimes crisscrossing the charges or balancing the charge. So if you look here at sodium and phosphorus, they would form an ionic bond. Well, of course they would. That's a metal and a non-metal. If I asked you to predict the formula, you're going to just write down what charge they would take using your periodic table and then balance the charge. So because this like right-hand side is like representative of -3, then the left-hand side would have to equal +3. How would you do that? You would need 3 sodiums. Now, we've done that where we've shown like the Bohr model, and we've like made the dots like the electrons like dots and used arrows and moved them around. You can look at it that way if you like. A lot of people look at it as crisscrossing the charge. We can talk about that when we come back. Now, this is something that even College Board could ask you. They could say, hey, if calcium reacts with like element X, and we know that the formula is CaX2, what would sodium and X do? Well, you just think about in terms of crisscross. You know calcium is in group 2. He's going to give away 2 valence, take on a +2 charge. And the fact that this formula required 2 of the X's, that means that X is -1. So you can say that X would still be -1 over here, and you know that sodium is going to be +1 based on the fact that he only has 1 valence. So the formula is just going to be NaX because they would already be balanced. Now, you're not going to crisscross the charges if they already net to 0. So do not do that, okay? If it's already netted to 0 at the top, you don't put the 2 in the 2. You want it to be the simplest whole number form. Now, element 117 was discovered as named Tennessee, and this is true, but my periodic table doesn't show element 117 as that. I think yours also shows it as like uninseptium or something. I don't know, but this is true. I'll tell you that it would be in group 17, like the halogens. Okay, when you get into these newer synthetic radioactive elements, sometimes periodic tables are not up to date. But I will tell you that the symbol is TS. I'm almost 100% sure. So because you know that anything in group 17, like the halogens, wants to gain an electron and would always have a -1 charge, even though you don't know anything about that element, just from the fact that you know that things in the same column would act the same, you could predict it's -1 because it's saying assume that periodic trends are followed. And it's asking you what would the formula be when it goes with magnesium? Well, it would be MgTS2 because you're just crisscrossing the charges. These are some of the easiest questions. Okay, this was fast, so I am done. Be sure that you continue on and you check your answers and make notes of anything you struggle with. And I love you guys already, and I will see you very, very soon. And we will have a great year together. Have a great summer.